Hello guys, in this video I'm going to be solving an algorithms question with the title Valid Palindrome. Let's dive right in. The question states, a phrase is a palindrome if after converting all uppercase letters into lowercase letters and removing all non-alphanumeric characters, it reads the same forward and backward. Alphanumeric characters include letters and numbers. Given a string S, return true if it is a palindrome or false otherwise. I'll be implementing two solutions to this question. In the first implementation, I'll clean the input phrase. I'll clean the input phrase in two steps. In the first step, I'll remove all non-alphanumeric characters from the input phrase. In the second step, I'll convert all uppercase letters to lowercase. I'll call the result of the cleaning cleaned string. Then I'll go ahead to reverse the cleaned string. I'll call the result of reversing the cleaned string reversed string. Finally, I'll compare cleaned string and reversed string. If they are the same, then the input phrase is a palindrome, so I'll return true. If they are not the same, I'll return false, meaning the input phrase is not a palindrome. In the second implementation, I'll make use of the two pointers approach. I'll declare two pointers, a left pointer and a right pointer. I'll place the left pointer on the first character of the input string, while I'll place the right pointer on the last character of the input string. If the character on the left pointer is non-alphanumeric, I'll move the left pointer one character to the right. If the character on the right pointer is non-alphanumeric, I'll move the right pointer one character to the left. Also, if the character on both pointers are alphanumeric and they are the same, I'll move the left pointer one character to the right, and I'll move the right pointer one character to the left. At what point will I stop moving both pointers? I'll stop moving both pointers if the alphanumeric character they point to are not the same, or if the left pointer has gone past the right pointer. Now I'll go ahead to give a visual explanation of the first implementation. Let's assume we have a phrase, a Toyota. The phrase comprises uppercase A space, and the word Toyota. Now I'll go ahead to clean this phrase. The first thing I'll do is to take out all non-alphanumeric characters. So starting from the first character of the phrase, uppercase A is an alphanumeric character, I'll keep it. The space is a non-alphanumeric character, so I'll ignore it. Lowercase t is an alphanumeric character, I'll keep it. O is alphanumeric, I'll keep it. Uppercase Y is alphanumeric, I'll keep it. The next O is alphanumeric, I'll keep it. The next T is alphanumeric, and the last A is alphanumeric also. Now the next step in cleaning the input phrase is to convert all uppercase letters to lowercase. Now the first character here, which is uppercase A, I'll convert that to lowercase. The T is already in lowercase. The O is in lowercase. The uppercase Y, I'll convert that to lowercase. The other O is in lowercase. The T is in lowercase. And the last A is in lowercase. Now this will be my clean string. Now the next thing I'll be doing is to reverse the cleaned string. So starting from the last character, I'll move this direction up until the first character. So the last character is A, the next character is T, the next one is O, the next one is Y, the next one is O, the next one is T, and the last one is A. So this would be my reverse string. Now, since the cleaned string and the reverse string are the same, this implementation will return True. And this means that the input phrase, a Toyota, is a palindrome. Let's assume we have a scenario where the clean string and the reverse string are not the same. Then the solution would return false, meaning the input phrase is not a palindrome. Now I'll go ahead with the code implementation of this algorithm. So the first thing I'll do is to declare a variable that will hold the clean string. I'll call that variable clean string and I'll set it to an empty string. And the next thing is to iterate over every character in the input phrase. I'll call the current character at index I current character. The next thing I'll be doing is to check if current character is alphanumeric. To check if current character is alphanumeric, I'll write a separate JavaScript function for that. I'll call the JavaScript function is alphanumeric. This function takes a string as a parameter and returns true if the string is alphanumeric. It returns false if it's not. To implement this function, I'll be making use of a concept in JavaScript known as regular expressions. Regular expressions are a way for you to test if a combination of characters matches a pattern. Since regular expressions is beyond the scope of this video, I'll include a link in the description for you to learn more about regular expressions. Now I'll go ahead to create a pattern that will match alphanumeric characters. Next, I'll call the test method on the pattern. Now the test method returns true if the string matches the pattern and returns false otherwise. Lines 17 to 21 can be written in a more concise form. So I'll comment out lines 17 to 21 and I'll replace those lines with this instead. Now that I have a function to test if a string is alphanumeric, I'll go on to test if current character is alphanumeric. If current character is alphanumeric, I'll go ahead to add the lowercase version of current character to the clean string. And I'm adding the lowercase version of the current character because the question states to convert uppercase letters to lowercase. So clean string becomes this. And to convert a string to lowercase in JavaScript, I'll use the JavaScript to lowercase method. Line 12 can be written in a cleaner form. So I'll comment out line 12 and rewrite line 12 as this. At the end of this loop, I'll have the clean string. The next thing I'll be doing is to reverse the clean string. So I'll write a separate JavaScript function to reverse the clean string. I'll call the JavaScript function reverse string. This takes a string as a parameter and returns a reversed version of the string. Now to reverse the string, I'll be doing it in 3 steps. Now the first step is to convert the string into an array. The next step is to reverse the array. Then the last step would be to join the elements of the reversed array into a string. So for the first step, which is to convert the string to an array, I'll use the JavaScript split method. So I'll save the result in a variable called sArray. Pass an empty string as a delimiter. Now the next step is to reverse the array. So I'm saving the result of reversing the array in a variable called reversed array. Now the last step is to join the elements of the reversed array into a string. I'm saving the result of reversing the string into a variable called reverse string. Then finally, I'll return reverse string. I can write lines 35 through 39 in shorter form. So I'll comment them out and I'll return these instead. Line 41 is using a concept in JavaScript known as method chaining. So I'm calling the split method on the string s, and I'm calling reverse on the result of the split method. I'm calling join on the result of the reverse method, and I'm returning the result of the join method. Now that I have a function to reverse the clean string, I'll go ahead to reverse it. Next, I'll go ahead to compare if reverse string and clean string are the same. If they are the same, I'll return true, meaning the input string is a palindrome. Else, I'll return false. I can write line 19 through 23 in a shorter form, so I'll comment this out, and I'll just return the result of comparing both strings. Okay, now I'll go ahead to check if this implementation is correct. I'll run the code. This has passed. I'll go ahead to submit. Okay, these has passed too. The next thing I want to talk about is the time and space complexity of this algorithm. The time complexity is big of n. and the space complexity is big of n also. The time complexity is big of n because the most expensive operations in the algorithm will take big of n time to complete. Now, the first of these operations is the for loop, with which I go through each character in the input phrase and then check to see if the character is alphanumeric. And if it is, I'll convert it to lowercase and add to the clean string. So if you have an input string of length n, it will take n operations for the for loop to complete. The second expensive operation is reversing the clean string. So if you have an input string of length n, which comprises entirely of alphanumeric characters, after cleaning the input string, you would have a clean string of length n also. And for you to reverse a clean string of length n, it will take n operations, which results to big of n. Now you may argue that the total time complexity should be 2 big of n, which is right. But then 2 big of n approximates to big of n, and that is because in big of n notations, constants such as 2 in this case are ignored. The space complexity, like I said earlier, is big of n also, and that is because of the extra space required to save the reverse string. So if you have a reverse string of n characters, it will take an extra space in the order of big of n to store it. Now I'll go ahead to give a visual explanation of the second solution. So I'll start with the phrase a Toyota. And the next thing I'll be doing is to declare 2 pointers, a left pointer, which I'll denote with L, and a right pointer, which I'll denote with R. So I'm placing the left pointer on the first character of the input string, and I'm placing the right pointer on the last character of the input string. Now the next thing I'll do is to compare the characters at both pointers. Now the character on the left pointer is uppercase A, and according to the question, we have to convert uppercase letters to lowercase. So I'll convert this to lowercase a, and now I'll go ahead to compare both characters. Lowercase a and lowercase a are the same. So I'll move the left pointer 1 character to the right, and I'll move the right pointer 1 character to the left. The right pointer. Now the left pointer is pointing to a space, and a space is not an alphanumeric character, so I'll ignore the space. I won't be doing any comparison, and I'll move it to the next character. Now I'll go ahead to compare the characters at both pointers. This is lowercase c, this is lowercase c, they are the same. So I'll move the left pointer 1 character to the right, and I'll move the right pointer 1 character to the left. Now both pointers point to the same lowercase character O. So I'll continue moving them. I'll move the left pointer 1 character to the right, and I'll move the right pointer 1 character to the left. Now both the left pointer and the right pointer are on the same position. Since at every point in time, both pointers are pointing to alphanumeric characters that are the same, will return true for this input phrase, meaning the input phrase is a palindrome. But let's assume we came across a situation where the alphanumeric characters at both pointers were not the same, then we would have returned false. Now let's try the same algorithm on the word big. So I'll place my left pointer on the first character. I'll place my right pointer on the last character. Now I'll compare the characters at both pointers. They are both the same alphanumeric character D. So I'll move the left pointer 1 character to the right. I'll move the right pointer 1 character to the left. Now I'll compare the characters at both pointers, they are the same. So I'll move the left character, I'll move the left pointer one character to the right, and I'll move the right pointer one character to the left. Now at this position, the left pointer has gone past the right pointer. So we'll stop moving the pointers here. And also, just like in the previous phrase, at every point in time, the alphanumeric characters at both pointers were the same. So we return true for this word. It means that the word D is a palindrome. Now let's check the final word model. Let's apply the same algorithm to this word model. So I'll assign my left and right pointers. My left pointer will be on the first character. My right pointer will be on the last character. Now I'll compare the characters at both pointers. L points to uppercase M, so I'll convert this to lowercase. This becomes lowercase m. Now I'll go ahead to compare the characters. They are the same, so I'll move the left pointer one character to the right. I'll move the right pointer one character to the left. Now I'll go ahead to compare the characters at both pointers. L points to lowercase o, R points to lowercase e. These characters are not the same. So I'll stop moving both pointers, but I'll return false for this particular word. It means that the word modem is not a palindrome. Now I'll go ahead to implement this algorithm in code. So I'll be keeping the is alphanumeric function I wrote in the last implementation. And the next thing I'll be doing is I'll declare the pointers, the left and the right pointer. So I'm assigning the left pointer the index of the first character in the input string, which is 0. And the value of the right pointer is the index of the last character in the input string. Now go ahead to implement the while loop to move the pointer. And the body of the while loop will keep running provided that the value of the left pointer is less than that of the right pointer. Now I'll get the value of the character at both pointers. So I'm saving the value of the character at the left pointer in a variable called left char. And I'm saving that on the right pointer to a variable called right char. Now the next thing I'll be doing is to check if left char is non-alphanumeric. So if left char is non-alphanumeric, I'll move the left pointer one character to the right. I can write this line of code on 14. So I'll comment this out. And I'll write this as this. After moving the left pointer one character to the right, I'll continue. And the reason why I'm continuing is because the left pointer has been moved to a new character. So I can compare this character with the already existing character at the right pointer. Now I'll go ahead to check if the character at the right pointer is not alphanumeric also. And if it's not alphanumeric, I'll move the right pointer one character to the left. Now can I write line 20 as this. So I'll comment out line 20 and I'll rewrite it as this. Then for this, I'll continue also. Now I'll compare the characters at both pointers, but before comparing them, I'll convert both of them to lowercase and test to see if they are not the same. If they are not the same, then I'll return false, meaning the input phrase is not a palindrome. However, if the alphanumeric characters at both pointers are the same, then I'll move the left pointer one character to the right, and I'll move the right pointer one character to the left. Now, at the end of the while loop, if at any point in time false was not returned, it means that we'll have to return true, and this implies that the input phrase is a palindrome. Now let me go ahead to run the code. This ran successfully. I'll go ahead to submit. This has passed. The next thing I would like to talk about is the time and space complexity of this algorithm. The time complexity of this algorithm is big of n. And it is big of n because using a while loop, I'm able to visit every character in the input phrase just once. You may argue that the time complexity should be half big of n because for each iteration, I'm considering two characters, the one at the left pointer and the one at the right pointer. But just like I explained in the previous implementation, constants are ignored in big of n notations. So half big of n approximates to big of n. The space complexity for this algorithm is big of 1, which is constant space. And this is because irrespective of the size of the input phrase, the extra space used by the algorithm is constant. The extra space used is just to declare the pointers and the respective characters at both pointers. Second implementation can be improved a bit. So instead of checking if the characters at both pointers are non-alphanumeric and then using the continue keyword, I can use a while loop to continuously check if the characters at both pointers are non-alphanumeric. However, that will not be implemented in this video. In our first implementation, we had a runtime complexity of big of n and a space complexity of big of n also. In the second implementation, we had a time complexity of big of n. However, we had a space complexity of big of 1, which is an improvement on the first algorithm. So that's it for this video. Thank you for watching. Like and subscribe to my channel for more content on tech education. I'll see you guys in the next one. Cheers.